talk about meta-modern software architecture. And I should lead this by saying this has nothing to do with meta as being tried to be claimed by the company formerly known as Facebook. This way predates Facebook, and they are not allowed to take the term meta from us because it's too useful for too many things, which I'm going to highlight today. As speakers and writers, we're always looking for metaphors and parallels between things. And as Mark Richards and I were writing our Fundamentals of Software Architecture book, the middle part of that book really does a deep dive into all of what we call architecture styles, which is distinguished from patterns in that patterns can exist on top of any of these styles, but these are kind of the named topologies that we have in software architecture. But that kind of begs the question, where do these things come from? Is there a giant ivory tower somewhere that all the architects go to and say, okay, what's the next thing we're going to do as an industry? Maybe it'll be called Microservices or something. That's not the way it happens at all. These things are always reactive, and they're almost always named after the fact. Because what happens is, the software development ecosystem that we live and work in is constantly shifting and changing and churning in new ways, and brand new things pop up, and occasionally some new thing will come up, or more likely some combination of new things will come up. The really clever architects will go, hey, you know what? If I took two of those and one of those and built this one that way and stuck it on there, that's a brand new approach to solving a problem. Like Netflix saying, what if we didn't host our own data center and did it on Amazon's data center? That's taking advantage of a new capability. And what happens is enough architects start doing that until other architects go, oh, look, they're solving that problem that way. Maybe we should solve it that way too. And eventually that becomes one of these named architecture styles. These are not pre-planned, but they're more a reflection of the things, the way we react to the ecosystem that we're within. And I was curious about the parallels here because as I was thinking about the way these things come about, they're a reflection about sort of the culture of how we're doing software development at the time. The parallel that really struck me was something that I've read a lot about in the last few years, and that's what we call cultural movements. This is this idea, but writ large on society as a whole. And I want to call out a couple of these cultural movements because we're, of course, in one of them right now. The first one I want to talk about is Victorianism, which was from 1800 until about 1901. So that one is a long one, it lasted almost a century. Of course, centered around Victorian England because that was sort of the center of the world at that time. And this was a time that was political liberalism. As we know, democratic governments came into the forefront and monarchies sort of started fading away. And notice this didn't just happen in the UK. This was something that happened worldwide, which is why it was eventually named as a movement. This is when industrial reform started happening, and you saw a lot of people moving toward larger groups. This is where a lot of what we today call science came from, the innovations that happened during the Victorian times. And a lot of classifying the natural world was considered one of their goals in this time. This is where representational art really started taking off, because as soon as cameras existed, artists didn't have to capture nature the way it is, they could interpret it. And we get things like Expressionism and other sorts of artistic movements, and that really kicked that off during the Victorian era. The Victorian era was followed by, and naming things are hard, and if you think naming things in software are hard, try naming entire cultural movements. So all of these names are terrible, and I didn't come up with them. I'm just reporting on them. So if you think we're the only ones who suffer from this, trust me, it gets way worse. Because the period that came after Victorianism is called Modernism. You can see the obvious flaw of calling anything Modernism because what's going to come next, but we'll see. So Modernism was from about 1890 until exactly 1945. And Modernism was very much about the development of industrial societies, and this was really encapsulating the Industrial Revolution, and this was a massive shift from a rural agrarian economy to more urban kind of manufacturing. There were backlashes against that. And this is true for all of these cultural movements. They really reflect a shifting perspective of people because things are different, because capabilities, technologies are different. Where we live is different, and that changes your attitude about the way you perceive the world. which is really about what these cultural movements are about, is how people perceive and interpret events that are happening in their world. The modernist world gave us theater of the absurd. This is Waiting for Godot, which has no meaning whatsoever on purpose as a piece of art. This also gave us one of my favorite artistic movements, abstract expressionism. This is, of course, Jackson Pollock, and they were trying to get away from representation entirely. And notice this was a backlash against Victorianism, which a lot of that was precise interpretation. They were trying to do the opposite. And even Jackson Pollock got frustrated because he would show these paintings and people would go, oh, I see, a horsey and a doggy and a rabbit. And he said, no horsey, no doggy, no rabbit, it's abstract. And so the ultimate kind of end of that path was my favorite artist of this era, which is Mark Rothko. And he solved this problem by just painting fuzzy rectangles. Because you can't see a doggy, a rabbit, or a horsey. In these, you just see a fuzzy rectangle. So very, very abstract, in fact, as abstract as it can be. But this is also the era that gave us radio. And media changes us a lot because of the way we consume material and react to it. So, modernism lasted until 1945. The thing that came after it was, of course, postmodernism. Again, names are hard. And this one is, so now, what comes next? So now we're just digging a deeper hole for ourselves. But okay, postmodernism is 1945 until about 1990. And postmodernism, like many of these cultural movements, was sort of defined by an anti-reaction to the thing that came before. So everything that's not modernist is basically what postmodernism was. So a lot of skepticism. The overwhelming emotion that came through in art in this era is irony. And I'll talk a little bit more about that in just a bit. But this was questioning everything. And this is where, in popular culture, you started getting these kind of rebellious figures, like the Beat Writers, Jack Kerouac, Neal Cassidy, etc., or William Burroughs' Naked Lunch, which was primarily written while stoned on heroin. And you get these countercultural figures like James Dean and Marlon Brando as the sort of exemplars of this era. And of course, the big change that happened here was television. If anything can change society, television can certainly do that. And one of the things that increasingly became apparent as we walked through the postmodern era is this reliance on irony as almost the dominant emotion. I'll come back to that in just a second. For example, Seinfeld, the sitcom, which was super popular during this era. The mantra for the show was no hugging, no learning. We never hug and we never learn from our mistakes. That was part of the mantra of the writers of that show because everything had to be dripping with irony. I'll say more about that in just a second as well. So that was postmodernism. But that means that the next one I talk about is the one we're living in right now. And there are two names that are common for this era. One of them is postmodernism. I'm not kidding. That is one of the accepted names, which I guess we just start tagging on with exponents or something. But the more common name for the era that we're living in right now is Metamodernism. It started in about 1990 and is extending right now into the era that we're in right now. The person who really defined a lot of the early part of Metamodernism is actually one of my favorite authors, David Foster Wallace. And he wrote this phenomenal essay. He wrote a lot of nonfiction essays and some fantastic novels as well. And in this book of essays called A Supposedly Fun Thing I'll Never Do Again, which was his story about going on a cruise ship, so you can tell what his attitude about that thing was. But he also wrote in this essay, or in this book of essays, an essay called E Unibus Plurim, Television and U.S. Fiction. And he brought up two interesting facts that how damaging television is to writers. Because writers naturally want to observe people, but writers are also frequently very shy and don't want to be around people. So how can you observe people and not be around them? TV is the perfect drug for that, because you can sit and watch them on TV, and actors are designed to be watched, but act like they're not being watched. The problem, though, is that when you have a first generation of writers who only write based on things they see on TV, the next generation, everything is flattered. Because they're not experiencing the real world, they're seeing this weird artificial world, and then the next world is even flatter. And so what do you end up relying on? Irony. That becomes the dominant thing. That's the only thing you can write about because you don't experience anything else. He also wrote Infinite Jest, which is considered one of the great first meta-modern novels. Very sprawling, very, very good book. But that sort of brings up the point of what really pushed us in the early 90s from the postmodern era to the meta-modern era. As I said before, it's frequently things like media, and here, of course, it was the internet. But this actually drives one of the most important characteristics of metamodernism, which I'm going to apply to software architecture here in just a second, in that the postmodern world was very singular about we can solve this problem in a particular way and we're done. But once the internet exists, you can't really have that attitude anymore. So a couple of examples. Let's say that it's 1989 and I need to travel to Chicago next week. I need to find out what the weather is going to be like in Chicago next week. How can I do that in 1989? No internet. I could turn on the Weather Channel and wait until Chicago eventually cycles around, or I could be really intrepid and go to the library and find a Chicago paper and see if there's a weekly forecast in it. But you know what I'm most likely to do is say, I don't know, I'm going to guess what the weather's going to be and I'll just dress accordingly. Because it's just too much trouble to go find out that information. Now we can have a race in this room to see in what sub-second time you could tell me the weather in Chicago next week. Every single person in this room could tell me in less than 5 seconds what the weather in Chicago is next week. Because it's just instantly available now. Let's say that in 1989, I wanted to write something about wine. So I'll go find wine magazines. I might find some wine books that cover the subject. I'd even be lucky enough to have a VHS player and find a videotape, documentary about wine. But you know, when I'm done, I've probably covered 70 or 80% of all the things that there is to know about wine. Good luck doing that for any subject today, because it's going to keep growing. If I could even learn everything there is about wine on the internet today, by tomorrow there's going to be that much more of it. It's never ending, and everything is multifaceted in this world. You can't really pay attention to a single thing anymore. And one of the driving characteristics of metamodernism is this holistic view of the world. The internet doesn't let you hide behind simple perspectives anymore because it shows you that there are lots and lots and lots of things everywhere. But that's actually one of the driving features of the entertainment of this era. A lot of people really love the show Parks and Recreation, which is one of the very first metamodern shows because it was so outside of itself and it was poignant, it was funny, it was all those things. The characters had depth to them, which is unusual for a sitcom like that. There's a great article by Seth Abramson, who's an author and writer about metamodernism. And there a lot of metamodern things are more rounded than the art that came before. A great example of this is Breaking Bad, which is deep in multiple ways, because not only is every character both good and bad, and there's no single good or no simple characters, but there's also all this deep symbology. So if you don't know this about Breaking Bad, this will be a real treat, because you can go back and watch the entire series with this lens on. Breaking Bad is based on color wheel. So one character's named Walter White and the other's named Pinkman. So it gives you a clue that color is important. And in the Breaking Bad universe, things that are yellow, which includes khaki, are safe, wholesome, unbroken good things. And everything that's purple is unsafe, drug-related, and Breaking Bad. There's a scene where a character takes off a yellow shirt and puts on a purple shirt because he's about to go do some evil stuff. So everything in the series is actually pointed to by the color theme that goes on, in addition to having all these well-fleshed out characters. One of the most popular shows right now is Ted Lasso. One of the things that David Foster Wallace predicted was a return to genuine sentimentality. Because as he said, you can't live on irony alone, and there will come a time when genuinely, unabashedly sentimental entertainment will become popular again. And lo and behold, here we are. So this holism is the thing that I really want to talk about, because this, like I say, these culture movements infect the way we think about everything, including technical things like software architecture. So let's talk about holism and how it applies to software architecture. I mentioned before that almost all of these software architectures are named well after the fact, after lots of people have built things in them. But just like with the cultural movements, once you realize you're in one of them, you can become sort of meta about watching it grow and how it changes. And that very much happened with microservices. This is the article back in 2014. So we're almost at the 10-year anniversary of this famous article on Martin Fowler's website by Martin Fowler and James Lewis, where they really described microservices. They didn't coin the term, they definitely made it really popular. And this is still one of the most viewed pages on Martin Fowler's website because people still go here. But rather than letting people stumble around and make a lot of mistakes and break stuff a lot in this architectural style, what this allowed us to do was to say what it is, but maybe more importantly, what it isn't. I think this short-circuited a huge amount of churn as people tried to figure out what to use it for and what not to use it for, because it gave us some scaffolding and some guidelines to think about how this stuff should fit together and what you should and shouldn't do with it and what the philosophy is. And I think that has helped it avoid the dreaded Gartner, a trough of disillusionment that we've seen so far. The other thing that's interesting about microservices, so Mark and I, as we were writing the Fundamentals book, we've done a lot of consulting around microservices, and we were wondering, why is it so difficult? Why are decisions so difficult in this world? And a lot of it has to do with this kind of holistic approach of data as part of a bounded context. Of course, microservices is based on this idea from domain-driven design of a bounded context. But if your data is part of that bounded context, that means that things like transactionality become an architectural concern, which complicates things greatly, but it also gives you new capabilities, which I'll talk about here in just a second. And so in many ways, this really is realizing what should be together and what shouldn't be together. We codified a couple of laws in our Fundamentals book. First, these are things that as we were writing through the book, we were looking for things that seemed universally true. We codified two of these things, and one of them is this one. Everything in software architecture is a trade-off. This seems to be the defining characteristic of things in the software architecture world. And in fact, the advice here is if you think you found something that isn't a trade-off, you probably just haven't discovered what that trade-off is yet. But let me give you some examples of this, because this is exactly the conversation I keep having with clients over and over again about reuse in architecture. So back in the service-oriented architecture days, one of the goals of that architecture was maximize institutional reuse. We're tired of duplicated stuff around, so let's maximize reuse. So let's say you're a big insurance company, and you have all these different divisions in your insurance company. And at some point, as an architect, you notice, and you were instructed to look for this in this era, hey, wait a minute, all of these parts have some aspect of customer in it. Slightly different for each one, but hey, there's definitely a commonality there. So, what I should do is consolidate all those customers together into a single customer service and just let all the insurance divisions talk to it. Great. Institutional reuse. Now, everything we know as an organization is about customers in that one customer service, which is awesome. We've managed to reuse that. But everything in software architecture is a trade-off. So what's the trade-off of this reuse that you've achieved? Well, there are two of them. One of them is survivable, and the other one is not. The survivable one is complexity. Because if this customer service has to know everything we know as an organization about customer, it's going to be complicated. And in fact, travel insurance doesn't really care about commercial insurance properties and attributes and methods and all that, and casualty insurance, but they've all got to be lumped together. And they've all got to agree with each other about how things are represented, et cetera, in that big customer service. And that drives a lot of brittle complexity, which is the worst part of this, why it's not survivable, and why we don't do a lot of service-oriented architectures anymore. Coupling. I keep hearing clients tell me, we want a really highly decoupled architecture, and we want a high degree of reuse. That's misunderstanding trade-offs, because my follow-up is, well, you know how we achieve reuse, right? By coupling. That's kind of the definition of reusing something, is coupling to it. So you cannot have high degrees of reuse and low coupling at the same time, because they are literally counter to one another. This was the great observation from domain-driven design, that you can't, the more you let coupling spread out in your architecture, the more damage it does. Because now, if I make a change to that customer service, even if that change doesn't really affect the other ones, they've all got to stop and coordinate around that change. If you build an entire architecture around brittleness, then every time something changes, you have to go back and change that thing. So rather than do this in the microservices world, the advice is to prefer duplication over coupling. Because this is a great example. Neither of these is good. What's the least worst one of them? This is the thing we get to in software architecture a lot, is not what is the best, because the best is not available, because there are too many trade-offs, but what is the least worst? And in many cases in microservices, duplication is better than coupling, because they're both bad, it's just the degree of how bad they are. But this is a great follow-on example of taking a concept like this and applying this kind of holistic view to it. Because, okay, the goal here is to keep domain things really decoupled from one another. We understand the benefits of that. But what about the things that we actually benefit from coupling together? Like all the operational plumbing, monitoring, logging, authentication, authorization, circuit breakers, all those kind of things. That's where this idea of service mesh comes from. Because if you have all these different services and you realize that they all have these common operational things in them, the common pattern has grown into what's called the sidecar pattern. Let's put all those common shared operational concerns in a sidecar, and if we can assume every service has one of these sidecars, we can build this idea of a service mesh, connect all the operational bits together, and leave all of the code decoupled from one another. So the domain's still decoupled, but now we've coupled it along one dimension, which are all these operational couplings. That's why service meshes are very popular right now. But wait a minute, you say, we do reuse stuff successfully. So let's talk about how you shift your thinking to become a meta-modern software architect. Because the realization that it takes is that there's no such thing as silver bullets in our world anymore. They're all either used up, or they were never any good to begin with, or for whatever reason, in architecture, there just are no clean, generic answers to questions. And your job as a software architect is not find silver bullets everywhere. You do a better service to your company if you are the objective arbiter of trade-offs. When a unique problem comes up, and guess what? Every problem in your architecture is unique, because nobody else in the world has the exact combination of things that you have in your architecture. When a unique problem come up, if you can hone your skills to do really good trade-off analysis, that's a huge value to your company. So let's talk about a trade-off analysis and what that really looks like around things like reuse. There are two aspects of reuse to make it functional. And the first one is one that everybody gets right, which is abstraction. Oh, look, all these things need the same abstraction. Let's extract that and reuse it. But everybody misses the second one, which is slow rate of change or volatility. Things that never change are really good targets for reuse because you don't have to stop and coordinate around the change. And think about things that we do successfully reuse all the time. Frameworks, libraries, operating systems, but they all have a formal release cycle. In fact, they notify you when it's time to sync up with them because they have a very slow rate of change. You see the hexagonal architecture pattern talked about a bit. I'll talk a little bit more about service mesh here. The hexagonal architecture pattern, which Alistair Coburn came up with many years ago. And this was almost exactly right. The thing that he missed in hexagonal architecture is the idea that business logic is in the center is a great idea. The thing he missed was the database is not just another adapter. It's got to be part of the bounded context, because that schema information is very tightly coupled to your business logic. And really the difference between the hexagonal architecture and the microservice is basically that. This encapsulates data, which of course leads you to needing to worry about data, transactionality, et cetera, at the architecture level. And that, of course, leads to this idea of service mesh that I talked about before. But let's take this step one step further. So service mesh and the sidecar pattern is, in fact, a pattern about how to do orthogonal coupling against what your normal coupling is. So our normal coupling in architecture is around operational data, capturing transactions, doing sales, etc. But what about analytical data? This is something we've struggled with in architecture a lot, is how do you manage this kind of analytical data, which is cross-cutting the operational data. We tried a bunch of things like data warehouses, but that just drives a huge amount of needless complexity. Data lakes are too unstructured, and we have a hard time piecing the right things together, and we expose too much stuff very often. The next generation of thinking about this is this idea of data mesh, which my colleague Zhamak has come up with. And in the idea of data mesh, it borrows that idea from service mesh, but extends it. Because if you have, for example, a service, what data mesh defines is what's called a data product quantum. So for an alpha service, you would have an alpha data product quantum, which is its own bit of code, maybe even with its own data store, but it is tightly coupled to your service, and it is responsible for reporting to data aggregators and business intelligence and other parts of your ecosystem. This is what we call a cooperative quanta, because they are coupled together, but they are loosely coupled together, and they are meant to be very tightly joined from a contract standpoint, because as the service changes, the analytical data will change. But that analytical data forms this kind of orthogonal plane where orthogonal data can flow through my architecture and not interfere with the operational data at all. The operational data is still managed by the services. It's these data product quanta that pull relevant data out of the operational data store, maybe refactor it, change it into something more consumable by business intelligence, and publish it to an analytics part of your architecture. And so this allows you the same kind of clean separation of concerns for analytical versus operational data that we get for things like service mesh. For example, in our book, we used a fake company that harvests, that does repairs, electronics repairs, called SysOps Squad. And so let's say that you have a ticket management business domain. Each of these services, like ticket management and assignment, have this cooperative analytical quantum, and they feed things into a tickets data product quantum that tells you things like all the tickets that have been serviced in this day filtered in a particular way, or in a tabular view of all those things. You may not want to host a tabular view of those things in your operational data store, but it's exposed through this data product. And the more typical use of this is you have this analytical data. Let's say you have experts and you have tickets that have been serviced and surveys. Well, I need to be able to hire the correct people to service electronics. I have to know what the industry trends are for who's buying what kind of equipment. Are people buying more computers or TVs or game systems? And so this is what feeds into that expert supply data product quantum. It pulls from the individual service data product quanta and builds up business intelligence around what kind of trend analysis we should use and to forecast who we should be hiring next. So this is a really innovative way to think about analytical data. We wrote one chapter about it in the Hard Parts book. Zhamak was one of our co-authors, and she's just released an entire book about this. This is a revolutionary way to think about data, and it's really adopting that sidecar pattern, but extending it in a way, because it's really about how do you create cross-cutting concern across distributed architectures. And of course, that comes from doing this analysis of trade-offs. One more example of this kind of holistic view of trade-off analysis in software architecture. One of the things that when Mark and I wrote the Fundamentals book, we kept bumping into problems that just got too deep too fast, that were too deep for a Fundamentals book. So we took all those problems and kind of set them aside. And when we finished the fundamentals book, we looked at this giant pile of difficult problems we were setting aside and said, okay, why are these so difficult? What's making these problems a special category in software architecture? And we had, I think, some real insights into a lot of it had to do around coupling, and particularly the most difficult problems tended to be, how do I figure out how to do communication between services because of all these competing forces? And we realized that there are really three primal forces at play here when you have two or more services call one another and transactionality might be involved. And the first of these is consistency. Is it atomic, meaning the whole workflow acts like a single thing, or is it some flavor of eventual consistency? Communication. Is it synchronous or asynchronous from a communication standpoint? And the third is coordination. Is it orchestration or is it choreography? It's just a pure accident they all ended up as C's, in fact, all CO words. And what we would do is look at all of these examples and notice that, well, if you change consistency from atomic to eventual, you've got to reevaluate the trade-offs for the other two. Now, what that made us realize is the mistake most people are making is this narrow single-dimensional view, because this is really a conjoined three-dimensional space. That every decision here affects all three of the dimensions. It's a very holistic kind of view of software architecture. And if you know a little bit about statistics, we have basically three binaries, which means there are 8 possible combinations. And what's interesting about this observation is, right there at the origin, orchestrated, synchronous, atomic, that's a monolith. It's only when you start pulling apart these distributed forces that you have to start thinking about where this little ball ends up. And so we ended up thinking, well, there are 8 possibilities. Let's model all 8 of them. And that's exactly what we did. All 8 of these possibilities. We modeled and did a qualitative analysis to see what happens if you look at all these different combinations of forces. And we thought, some of these will be just obvious throwaways that nobody would ever do that. And it turns out that every single one of these is legitimate, either as a pattern or an anti-pattern. These are all types of sagas in the distributed computing world, so we gave them all clever names about what kind of saga it is. It has to do with how broad the transactional scope is, whether it's synchronous or asynchronous, every possible combination of these things. But an interesting thing happened when we did that. It gave us a much better feel for the entire problem space. Because one of the observations you commonly get in distributed architectures is, you should avoid orchestration. Because orchestration drives a lot of complexity. And sure enough, if you look at orchestration here and the epic saga, a lot of red dots, a lot of complexity, a lot of badness. But is it because of the orchestration? Because when you look over here, the parallel saga, much fewer red dots. Turns out it's not orchestration, it's the combination of orchestration and atomicity. Because doing this holistic analysis, what it shows you at the end is what forces drive coupling up and what forces drive coupling down. And this lets you make more informed decisions. As you're making decisions between these, can I withstand less coupling or more coupling to get higher scalability? So it gives you decision points to make because you understand how these forces interact with each other. There's a huge value of doing this kind of analysis, what we call qualitative analysis, across the entire space, because not only do you learn something concrete, but it gives you a better feel for the kinds of decisions you need to make with less data in the future. So as I mentioned before, these cultural movements affect everything about us. And that includes not just the technical parts of software, but the other parts of software development as well. So you notice I mentioned that the modern era ended sharply in 1945. So let's talk about that for a second, the transitions. If you look at popular culture for 1945, physicists were considered kind of wacky, eccentric. This is the classic example of physicist Albert Einstein with his funny faces and his mismatched socks and all that. But I want to talk a little more about a different scientist, Richard Feynman, which I'm sure many of you are familiar with. There are a couple of reasons I want to talk about Feynman, one of which is I am actually only a few degrees of separation from Richard Feynman. So you're familiar with this idea of 6 degrees of separation, which came up in this play, but it's this really interesting observation that when you start counting connections between people, that everyone is at maximum 6 degrees of separation from everyone else. You may have heard the popular game 6 Degrees of Kevin Bacon, because Kevin Bacon has been in so many movies. You can actually get to Kevin Bacon almost instantly, and from him get to any actor in Hollywood, because he's met so many people. And I am, in fact, so this is the chart of 6 degrees of separation, because when you start talking about connectivity, it gets big fast. And I am, in fact, 3 degrees of separation from Richard Feynman, because one of my colleagues in Australia, Scott Shaw, used to work with Richard Feynman's son, and that gives me 3 degrees of separation from Richard Feynman, which means I'm 4 degrees of separation from Albert Einstein. So, see, these numbers get fast big. And so I'm actually just a few degrees of separation from lots of famous people. Feynman was fascinating because there are several books about how eccentric he was. And during World War II, he created the first parallel computer. And I'll show you a picture of it. It's right here. Because before 1945, if you looked up computer in the dictionary, it was room full of people who compute things. We didn't have computers then. And in fact, this is what computers looked like during World War II, almost entirely women doing math problems. But what Feynman did was invent parallelism. He figured out that some people were better at adding, some people were better at logarithms, and so he created a pipeline. And he figured out a way, if something gets broken, you didn't have to restart the entire thing, you could find where it broke, and he's color-coded, and he actually got some patents for concurrency theory as a physicist. And he also, of course, created quantum mechanics, which he's very famous for. He was also a bongo drummer. So this is about orange juice, by the way. He's very excited about orange juice. Somebody said of Richard Feynman, it's really good that he won the Nobel Prize when he was really young, because if you act the way he does and you have a Nobel Prize, you're eccentric. If you act the way he does and you don't have a Nobel Prize, you're a nut. In a way somewhere. But Feynman was also part of this transition from the modern to the postmodern era. The reason we can tag it at 1945, this is what pushed us from the modern to the postmodern era. And in fact, Richard Feynman is the only person to physically eyewitness the first atomic bomb blast. He worked at the Los Alamos Project, and they were in a bunker, and he knew enough about radiation. Everybody else was wearing welding goggles, and he knew enough that he was far enough away that he decided to risk it. And so he stuck his head up and actually saw the flash before he ducked his head down again. And he heard it, and he knew enough about the science, so he was the only person who actually physically saw that first blast. In the later part of his life, he was haunted by the work he had done at Los Alamos. A lot of the bright young scientists who worked there didn't really understand the implications of the thing they were working on. And he had a famous quote toward the end of his life. He said, with any project like that, you continue to work trying to get success, having decided to do it. But what I did, immorally, I would now say, was not to remember the reason I said I was doing it, so that when the reason changed, not the slightest thought came to my mind that meant that I now have to reconsider why I'm continuing to do this. His point was that the war in Europe was done, but they kept working on the atomic bomb because it was a puzzle they were trying to solve. It was a fantastic math and physics puzzle that no one had ever solved before. But when they solved it, somebody else took it over. They didn't like that. Robert Oppenheimer, who ran this project, suffered from this the rest of his life. And in fact, basically did a redemption tour and started several institutions to try to rectify the damage that he inadvertently did by helping that project. And that's when the mad scientist entered our cultural milieu, where mad scientists can do terrible things for the world that didn't really exist before that happened. That was the thing that pushed us from postmodern to metamodern, of course, is the internet. And this idea of holism contains not just technical decisions, but other decisions as well. Because if you look in popular culture, most programmers are viewed as sort of harmless. If you want to see a good postmodern picture of a programmer, you can see the cigarette in his hand. So that's a very dated photo. But this is kind of the common view of software developers now. Only for a short time. Because Volkswagen got busted cheating on emissions, and they suffered consequences from that. But you all know how technology works. Somebody, at least somebody, knew what was going on and had to design that software specifically to bypass that stuff. And some of them can claim ignorance, that some people knew what they were doing, that they were actively working to subvert the law. But if we're going to talk about companies who keep getting busted doing bad things, that inevitably leads us to Facebook. Facebook is interesting because they keep getting busted for doing terrible things over and over and over and over and over. Data breaches, which maybe they were partially to blame for. Illegally tracking users. Doing things like using your two-factor authentication number to send you marketing and send it out to other salespeople, which is not what you're supposed to do. We suspected a lot of this stuff for a long time. And then somebody showed up with receipts that showed the decisions made within that company that are not naive. They are purposeful, and in many cases, pretty evil, objectively bad things that they're doing to society. In fact, this last week, another story came out. Now, if you're Facebook, you have to understand how internet memes work, right? They are competing with TikTok. And so Facebook planted a story that there was a TikTok meme going around where students were slapping their teacher. That was made up by Facebook. But because they started reporting it, the way internet memes work, students started slapping their teachers and putting it on TikTok. It became a self-fulfilling prophecy. Somebody was in a meeting room and pitched this idea, and multiple people said, yes, let's do that. And it keeps happening over and over again. Sean Parker talks about this. He was a brief advisor at Facebook, and he said it's exactly the kind of thing a hacker like myself would come up with, this idea of using anger as a way to keep engagement. I would view that as a really clever hack, without thinking about what that's going to do to the people who are actually consuming all of that stuff. So that kind of begs the question, why do they keep doing this? Because they've been busted over and over again. And I don't know why. I don't have any insight into Facebook. I suspect that they could be a really good $250 million company with ethics, or a $3 billion company without. I think they've made their choice. Seems pretty clear from all the external and internal evidence that we have. But remember, these cultural movements are about everything in society. And modernism gave us balance sheet accounting. That has not always existed, It was invented. And when the stock market came along, people said, we need a single number to tell if a company is healthy or not. So, balance sheet accounting. If everything balances, then we're good. And this became to define the stock market and the way we value companies now, in many ways. In fact, this led to the famous meme that greed is good, because that's the only thing you care about as a company. In the postmodern era, we doubled down with quants. How can we hack the math and the system to figure out ways to cheat things? But in the metamodern world, we talk about the humane corporation. Because now we can't pretend that we're not all connected to one another. Everything is holistic. You can't hide from that anymore. In fact, Martin writes about this on his website, one of the philosophies of the driven ThoughtWorks for a long time, that we have to make a profit to survive as a company, but we're also very concerned about leaving the world a better place than what we left it. And that's what we mean by being a humane corporation. And that's part of this holistic view of the world, which for us really means a more careful evaluation of ethics in the way that we write code, in the way we produce software. Because we are all connected to one another to an amazing degree. And do you really want to be the computer scientist who comes up with something really cool and then spends the rest of your career on an apology tour? This is one of the creators of the algorithm at YouTube that makes people hate each other more. And he's going around doing interviews constantly saying, I feel horrible about what I did and what I helped unleash on our world. This is starting to happen within companies. Microsoft employees pushed back against their employer trying to buy more military contracts and said, we're not going to work on that stuff. Google employees have also pushed back against some of the things that they were trying to do in China because it's unethical. We don't want to use software to make the world a worse place. So Kara Swisher, famous tech columnist, asked this pointed question, who will teach Silicon Valley to be ethical? I know the answer to this question. It has to be all of us. It has to start from the ground and go up because we can't trust corporations often to be ethical. So, I don't necessarily endorse this site, but it has a great message for all of us who are creators of software. To those who have a choice, refuse to work on systems that profit from digital addictions. Refuse to work on systems that centralize control of media in an unhealthy way and removes choice. Refuse to work on systems that prop up an unjust status quo. Refuse to work on systems that require unsustainable trade-offs for things. I'm looking at you, Bitcoin, and some related technologies. Refuse to work on systems that weaponize the fabric of society just so you can enrich yourself. And above all, refuse to work on systems that understand and manipulate people but offer no affordance for their subjects to understand and manipulate them back. Remember, that free app you're using, you are the product. And they treat you like their product, and not even as a good product. Work on something that matters, if only to you, because you put passion into it. Work on something that helps people even in small ways. Work on making things more understandable, because there's too much complexity in our world. Once, software let a lucky few of us escape to virtual worlds, choose our own communities, and explore alternate realities. These days, for better or for worse, software defines everyone's reality. Let's build one that's worth living in. Thank you very much.